In this video, we'll talk really quick about confidence intervals. So a confidence interval basically tells us what percentage of the time that we're willing to be wrong. And the general rule of thumb for social science is that the lowest we go is 95%, meaning that we could be wrong 5% of the time. Some studies will take it even further and do a 99% confidence interval, meaning that they'd be willing to be wrong 1% of the time. So we have some data, and we've randomly sampled n observations from a population of size n. I want to find a symmetric interval such that I'm confident that the true population mean lies within that interval, between those two numbers. So for example, how about the income of Philadelphia residents? I want to find some kind of interval, AB, such that I'm confident that the true population mean will be between those two numbers. I want to be able to say, with 95% confidence, that the mean lies between A and B. 95% confidence means that I could be wrong 5% of the time, or there's a 5% chance that my calculations are incorrect. So there's a little bit of notation with confidence intervals. Alpha is going to be our error rate, and our confidence level is 1 minus alpha. So we have a specific kind of error here. We are 1 minus alpha % correct that our sample statistic falls within the range of the confidence interval. And this will all become a lot clearer once we illustrate it together in Excel and R. A is the rate at which we are willing to be wrong. So this is the rate at which the sample statistic will fall outside of the range of our confidence interval. This is the formula that we use to calculate a confidence interval. So in order to construct a confidence interval, you always need the sample mean, x, the standard deviation, s, and the sample size, n. Using the sample standard deviation, we can compute the standard error, the standard deviation of the sample mean. Then, we can select our level of confidence and take 1 minus confidence. That is our alpha value. So if our level of confidence is 95%, 1 minus 0.95 equals 0.5, which is our alpha. In social science, you most often see an alpha of 0.5, but alphas of 0.1 and 0.01 are also pretty common. So we construct a confidence interval that allows us to be 1 minus alpha % confident that the true population mean lies between our lower and upper bound. Using either the z-table or the normal cumulative distribution function, we find a value, z-critical, that corresponds with our confidence level, alpha. So we just locate the value in the table, and using the values in the rows and columns of the table, we find our z-star. Half of the remaining data is going to lie above our confidence interval, and half of the data is going to lie below our confidence interval, and this is what we mean by upper and lower bound confidence intervals. Then we compute the boundaries of the confidence interval using the following formula. Now, using Excel and R, you won't really ever have to do this by hand, but we will do it manually in Excel just so that you can get the mechanics behind how all this actually works and make it really make sense.